Okay, I want to make sure everybody knows what I'm doing here. It has nothing to do with Lenz's law of generator coils being swept by magnets. This is all about recovering the flyback spike, the back EMF of a DC motor coil pulse. So, let's say you have a motor coil pulse this long. Let's say it's 2 milliseconds. Now, you switch in and connect it to the capacitor, the load of the capacitor at this point with the second switch. So there's an overlap of this distance, okay, between the motor coil pulse and the connection of the back EMF flyback to the load of the cap. Okay, so there's the overlap period. That's maybe 3/4 of a millisecond if this is 2 millisecond pulse. Okay, now I made a little X. This is when the flyback spike happens, as everybody knows, upon the shut off, the opening of the motor coil switch. So you see this second switch has this covered. This is going to pull the flyback spike out. And then this motor coil pulse turns off. And then this is still pulling out stuff. I don't know a better word for stuff, but it's still pulling out stuff. It could be the ringing, or it could even be the back EMF, actually, the reverse magnetic field, which would be nice if that's happening too. During this period, when the motor coil has completely turned off, you've collected the flyback spike, and you still have this connection to the capacitor going on. This also might, this period here might be accelerating the rotor a little bit as the capacitor fills. And it's kind of like a continuation of a motor coil pulse a little bit, and if it is actually going in reverse polarity and causing some drag. Now the motor coil pulse is off, so if it's reverse polarity, this is just a theory. It's possible the timing of it can make it so it will push on the magnet forward rather than pull it back. This is just theory. All I know is this really works good. You have a connection here, and there's a little bit of an overlap. Okay, so in real world, here's the two Hall effects. The Hall effect on the left is the motor coil pulse. The Hall effect on the right is the connection to the back EMF. And of course I have this on a little slider so I can adjust the timing. It would be nice if I had a adjustment of the gap between these two, but I tested this before and by hand, and this was like the speed I'm going and the input I'm going. This is a good gap for it. It's supposed to be about 5 degrees retarded, the connection of the spike, the connection of the back EMF circuit, and I like to say it's like an echo. When you get it like an echo, you get it really working good. Okay, the advantage of this is when you fill up large capacitors without doing this, just like doing a motor coil pulse, have a steering diode coming off the drain of the MOSFET, and filling up capacitors continually all the time, during the motor coil pulse, which is kind of the normal way to do it. When you fill up large capacitors, it'll lug the motor down, make it go less RPMs, and make the draw go up, because it's kind of hitting a resistance of the large capacitors, that flyback. Again, I'm not talking about Lenz's law here. I'm just talking about collecting the flyback spike. And you know, if you short out the flybacks, this flyback spike, the steering diode going into capacitors, you just short it out without decoupling the motor coil pulse, it'll really cause problems. And and the same thing if you fill up very large capacitors. By very large, I mean like things over 100 UF, capacitors over 100 UF. You're going to see every time it fills that capacitor after a discharge, it's going to cause the draw to go up. So this makes it so the draw does not go up when you do it like this. So already we know that when you discharge a capacitor, if you have it decoupled, it's not going to affect the draw or motor draw or cause the rotor to slow. And so now the problem is filling the capacitor without the rotor slowing or draw going up. Well, this is the solution for that. Now, also, this is occurring at the peak period when it fills, because you know, if you look at a scope and a motor coil pulse, it's up there at the peak period of the sine wave as the magnets sweep by. So you're doing this at the peak period too. So if you wanted to do this like with Arduino or something, that's what you look for, is the peak period to sense when to do this. But that's another story there. Okay, so that's okay. I had some comments from this guy talking about, I don't know what Lenz's law is, and this is all a big mistake. And instead of arguing with him, I just deleted his message because he left some other bad messages. Very stupid. And so I just want everybody to know this is not about Lenz's law. This is about recovering the flyback. Now, on top of this Hall effect, I'm going to put a third Hall effect on top, and that will be, you know, tripped by these upper magnets 4 times the revolution, which I've shown before. These upper ones. So it's the same thing, 3 pulses, bang, bang, bang. Each of them will have this happen each time. So the capacitor will be pulsed 3 times with that second switch, and then there's a gap, and that's when it discharges. It does it again and again and again. So that's what's going on here. Okay, thanks for watching.